Okay, in the previous class, we have started February-March paper. So we are going to continue that one. We have ended over here to the part 2. Now, let's have a look at part 3. Calculate the maximum mass of iron metal formed when Fe3O4 is electrolyzed for 6 hours. So here we have provided with the time and a current of 50 ampere. Okay. Assume that one Fe2 positive and two Fe3 positive ions are discharged at the same rate. Okay. So this is the hint that is provided by the examiner, that in this compound, you have iron in the two oxidation states, and what they are saying that one iron 2 positive is discharging at a rate, and at the same rate, two Fe3 positive ions are also discharging and forming iron metal. So if you look, the net half equation would be 2 Fe2, sorry, okay, 2 Fe3 positive ions, 1 Fe2 positive ion, and 8 electrons forming 3 iron metal. Is this equation is clear to everyone?
Sir, एक question है.
Yes.
Sir, आपको कैसे पता है कि आपने इसको times by 2 करना है?
किसको?
जिसमें third oxidation state है.
See over here.
आप इसमें plus 3 electrons नहीं कर सकते.
यहाँ पे?
Okay, question में mention है. ठीक है, thank you.
Yes, it is mentioned in the question. So I have got this, that 1 mole of iron 2 positive ion and 2 moles of iron 3 positive ions. So in total, they are gaining 8 electrons and forming 3 iron metals. Okay. So from this, what I can conclude that if you see there are 8 moles of electrons, which means that 8 times 96500 charge is being consumed for the formation of 3 moles of iron. And we know that the AR, if you look in the periodic table, the AR of iron is 56. Can anybody just check and tell me, is this a right one or wrong?
Sir, it's correct.
Okay, so it's 3 times 56. So that is the ratio that I have made from the equation, that 8 times 96500 coulomb is used to obtain 3 times 56 gram of iron. Is this understandable? Now, in the experiment is performed for 6 hours, and whenever we calculate the coulomb, we convert the time into seconds. So it would be 6 times 60 times 60 to convert into a second, and then 50 ampere. So the product of this would give me a coulomb that is used in this experiment. And for that amount of coulombs, the mass of iron formed would be X. Is this understandable? Yes. बेटा अगर किसी को भी कोई क्वेरी है इसमें तो प्लीज पूछ लीजिए। हमने रेशो लिया है कूलम का और मास का। सो x वुड बी 6 times 60 times 60 times 50 times 3 times 56 divided by 8 times 96500. Yes, can anybody solve and tell me the answer? Yes.
235.0.
It's 235.0. So it would be 235.0. Okay, just give me a second. I have to just. Okay, so see over here. It's 55.8 in the A levels periodic table. So just take it 55.8, not 56. Now, can anybody tell me the answer?
Two 234.2.
Okay, thank you. 234.2. Okay. Now, part C. LiFePO4 can be used in lithium-ion rechargeable batteries. When the cell is charging, lithium reacts with graphite electrode to form LiC6. Okay. When the cell is discharging, the half equation for the two processes that occur as follows. So these two are the reactions that are taking place when cell is discharging, right? Okay. State one possible advantage of developing cells such as lithium-ion rechargeable batteries. I think all of you have seen lithium-ion batteries. The most significance of these batteries are they are very small size and hence produce a higher voltage than the other batteries. So you can write compact in size, but gives high voltage. Now, next part. use cathode half equation to determine the change, if any, in oxidation state of lithium and iron at the cathode during discharging. Okay, so here I have a half equation of cathode. If you look over here, here it is a positive 1 charge. If we talk about phosphate, phosphate is 3 negative, which means this iron have a 3 positive charge. So here phosphate is again 3 minus, which means this whole thing have a 3 positive charge. And when we talk about lithium, lithium as in its group 1, so it may have a +1 charge, but iron have a now +2 charge. So the change in iron is from 3 positive to +2, and the change in lithium is from +1 to +1, so it stays same. So for lithium, I'll write from +1 to +1, and for iron, it is from +3 to +2. Is this clear to everyone?
So, sir, how do you know the oxidation state of iron is 2 positive?
Okay. You are asking why the oxidation state of iron is changed, right?
Yes, like how do we know it?
Okay. Let me show you the working again. Okay. We know lithium is in group 1, so it have a +1 charge, right? When we talk about phosphate, as if we talk about FePO4, the net charge of the whole compound is 0. And we know that PO4 phosphate have a 3 minus charge, which means iron must have a 3 positive charge. Is this clear?
Yes, sir.
Okay. Now, if we work on this compound LiFePO4, lithium iron phosphate, there is no net charge, which means net charge is 0. And we know that phosphate PO4 have a -3 charge, right? So if phosphorus have a -3 charge, it means that the net charge of lithium and iron both would be +3, right?
Right.
Okay. We have a 2 elements, one is lithium and one is iron. Lithium is from group 1, right? But when we talk about iron, iron is a transition element, right?
Yes.
And we all know that transition elements have a property that they have a variable oxidation state, right?
Yes.
So from this, I would say that the lithium stays +1 and the oxidation state of iron must be changed.
Right.
Is it clear now?
Yes, thank you.
Okay. If anybody else have any doubt, kindly ask. Okay. Then third part, write the equation for the overall reaction that occurs when this cell is discharging. Okay. So if you look at these two, let me write the equations over here. It is LiC6 forming 6 carbon and Li positive ion and an electron. If you look at the half equation at cathode, we have Li positive reacting with FePO4 gaining one electron, right, and forming LiFePO4. So if you look at both the equations, this equation is showing me the oxidation and this equation is showing me the reduction, right? So, and both the equation have an equal number of electrons. So I just have to add both the equations, and when I'm going to add both the equations, the species which are same and are on the opposite side must be cancelled. So I cancel the electron from these two equations and the lithium ion from these two equations, because lithium ion is present in both the equations on the opposite side, and in the same way the electrons are present on the opposite sides of the arrows in both the equations. Now what I am left with, LiC6 reacting with FePO4 forming 6 moles of carbon and LiFePO4. Is this understandable?
Yes,
Yes.
sir.
Okay. Now,
सर ऑक्सीडेशन वाली इक्वेशन को फ्लिप नहीं करेंगे?
sorry.
ऑक्सीडेशन वाली इक्वेशन को फ्लिप नहीं करेंगे?
सी, ये मैं एक्सपेक्ट कर रहा था कि कोई भी एक पूछे ऑक्सीडेशन वाली इक्वेशन को. व्हेन वी इट इज ओनली फ्लिप्ड व्हेन we predict that oxidation is taking place and that equation written in the form of the reduction reaction. But see here, the electron are on the right side of the equation, so it is already flipped over here.
अच्छा सही 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 ठीक है, मतलब इलेक्ट्रॉन जब दूसरी साइड पे होंगे रिएक्टेंट साइड पे तब फ्लिप करना होगा.
Yes, when the electrons are over here and we predict that this reaction, the oxidation is taking place, then we flip that half equation. Otherwise, in this equation, the electrons are already on the right side, which means these electrons are lost and oxidation is taking place. So there is no need to flip the equation.
ओके ठीक है, थैंक यू सर.
Okay, now question number 3. Iodates are compound that contain IO3 negative anion. Okay, IO3 anion is shown over here. Okay, what is the oxidation number of iodine over here in this compound? Yes, can anybody tell me? What is the oxidation
Five.
number? Yes, good.
+5.
It's positive 5. Yeah, very good. It's positive 5. Okay. Now what they are asking, explain with a reference to the qualitative model of electron pair repulsion why the iodate anion has a pyramidal shape. Yes, see, it's from AS. Whenever you recall the pyramidal shape, let me give you a common example of the pyramidal shape. Ammonia always have a pyramidal shape, and it is because around ammonia there are 3 bond pair and 1 lone pair around nitrogen in ammonia, right? So let's have a look at iodine over here. This is a 1 bond pair this is the second bond pair and this is the third bond pair, right? So it have a 3 bond pairs. And when we talk about the lone pair, so if you recall, or if you look in the periodic table, iodine is from group 17 or group 7, which means there are 7 valence electrons, right? And out of these 7 valence electron, 1 electron is involved over here. 1 electron of iodine is over here, 1 is over here, 1 is over here, and 1 is over here. So 5 electrons are involved in bonding. So we are left with a 1 bond pair. So see, there are 3 bond pairs and 1 lone pair around the central atom iodine. So this arrangement of electron pairs around the central atom, which is iodine, leads to the shape pyramidal. So you may write that around central atom that is iodine, there are 3 bond pair of electrons and 1 lone pair of electron. Hence, iodate has a pyramidal shape. Yes, is this clear to everyone?
Yes, sir.
Now, the reaction of iodine and hot aqueous sodium hydroxide is similar to that of chlorine. And if you recall, this reaction is also discussed in AS group 17 topic. And hot aqueous sodium hydroxide, sodium iodate NaIO3 is formed as one of the products. Suggest an equation for the reaction of iodine and hot aqueous sodium hydroxide. So if you recall the similar reaction when happens with the chlorine, so chlorine and sodium hydroxide reacts to form NaCl and NaClO3 and H2O. And if you balance this equation, we need 6 moles of NaOH, 5 moles of sodium chloride is formed, and 3 moles of water are formed. This equation is present in, if you have a notes of group 17 from AS, you will find this equation over there. So what you need to do over here, you just need to displace or replace chlorine with the iodine. So, okay, I left one thing, 3 moles of chlorine as well. So three moles of iodine reacting with 6 moles of sodium hydroxide, forming 5 moles of sodium iodide, 1 mole of sodium iodate, and 3 moles of water. So this would be the equation. Is this clear to everyone? Yes.
Yes, sir.
Now, C part. The decomposition of hydrogen peroxide H2O2 is catalyzed by addition of iodate. H2O2 reduces acidified iodate as shown. Okay, here I have equation. The reaction is followed by the oxidation of iodine by H2O2. Okay. Here you have a 3 half equations with their E naught values. Use the data to show that the separate reaction of H2O2 with iodate and with iodine are both feasible under standard conditions. In your answer, give the equation for the reaction of H2O2 with iodine. Okay. So first talk about the reaction between. Now I'm going to ask you guys reaction between H2O2 and iodate. Yes. Can you figure out for this reaction out of these three, which two half equations we can use? Because I think in one of the previous session, we have a very detailed discussion about choosing the E naught values and the half equations. So which two half equations can be used for this reaction? Yes, Taha, repeat.
2 and 3.
2 and 3. Okay. If we look at equation 2, here I have a iodine and here I have a H2O2. So
Sorry, 1 and 2?
no, not 1 and 2. What? Okay, tell me why you say 1 and 2.
Because it has hydrogen peroxide and
Hydrogen
Yeah.
peroxide in the first equation as well as in the third equation, right? So, okay, let me tell you, for H2O2, if I choose equation 1, so what H2O2 have to do, either H2O2 have to oxidized or reduce. If I choose equation 1,
Reduce.
reduce, okay. And why it undergo reduction? As it is on the left hand side. Okay. So if this is the case, then the species in other half equation must be oxidized. So it have to be on right hand side. Did you understand this, Soliha? And everybody else as well. You have to be very clear about this thing when we choose any equation, and if in that equation our species on the left hand side, then it must undergo reduction, and with the other species with which it is reacting must be on the right hand side of the other half equation. So if I choose 1 and 2, there would be no reaction between H2O2 and IO3 negative in this case, because both are gaining the electron. So how this possible that one gains the electron and the other also gains the electron? ये बात समझ में आ रही है सबको? If one is gaining the electron, then other must lose the electron in order to reaction to occur. ये point clear है या नहीं clear?
Yes, sir.
So if I choose equation 2 and 3, then the reaction will occur because H2O2 on the right hand side, so it will oxidize, and IO3 on the left hand side, it would reduce. And we have discussed earlier that the one which reduces have a greater value, and one with the which oxidizes have a lower value. So for a reaction between H2O2 and IO3 negative, so if you see E naught for, we take one equation O2 and H2O2, the value is positive 0.68, which means it would undergo oxidation, and E naught for IO3 negative and iodine is positive 1.19, which is a greater value, which means it would undergo reduction. And if you find the E naught cell according to this, which is reduction minus oxidation, so see, you will get the positive answer, positive 1.19 minus 0.68. Can anybody tell me the answer? जी कोई आंसर बताएगा प्लीज?
0.51.
And it's a positive, right?
Yes.
So if it's a positive, then we can say the reaction is feasible. Now let's have a look for the reaction between hydrogen peroxide and iodine. Now for this case, if you look, we have a iodine on the left side, right? And H2 on the right side, so it means H2O2 must be reduced and I2 must be oxidized. And if you see, the one which is undergoing reduction have the greater value, and the one which is undergoing oxidation have a smaller value. So yes, this reaction also occur when we are comparing H2O2 and iodine. So the E naught value for O2 and H2O2. No, sorry. H2O2 and H2O is positive 1.77, which means it's a greater value, so it will undergo reduction, and E naught for IO3 iodine is positive 1.19, which means it would undergo oxidation. So if I'll find the E naught cell, reduction 1.77 minus oxidation, which is 1.919. Can I have the answer, please?
Positive 0.58.
Positive 0.58. So it is also feasible because we are getting the positive value. Okay. Now,
सर हम आंसर इस तरह लिख सकते हैं, ये मतलब वैल्यूज और सब डाल के, जरूरी नहीं है कि पैराग्राफ फॉर्म में लिखें।
नहीं, आप इस तरह आंसर लिख सकते हैं, बिल्कुल। आपने शो कर दिया ना पॉजिटिव साइन के साथ।
ओके ओके
So you
सर।
can write the answer in this way as well. Now, next part is that you have to write the equation for H2O2 and iodine. So see, H2O2 is undergoing reduction. So I will take this value. Iodine is undergoing oxidation. So I'll take this equation, but this equation must be flipped. As discussed earlier, now see, why I'm flipping this equation? Because see, इस इक्वेशन में भी जो फॉरवर्ड रिएक्शन है वो रिडक्शन हो रहा है, और हमने जो कंक्लूड किया है, that conclusion tells me that oxidation will occur, which means backward reaction takes place. So that's why I have to flip the equation. Okay, so first write the first equation. H2O2 plus 2 hydrogen ions and 2 electrons forming 2 moles of water, and then half mole of iodine plus 3 H2O forming IO3 negative plus 6 H positive plus 5 electrons. Now I have to add these two equations, but before adding, if you see, both the equations have different number of electrons, right? So I have to first equal the number of electrons. So if I multiply the first equation with the 5, so it would become 5. This would become 10. This would become 10. 5 times 2, 10. And this would become 10. Is this understandable to everyone? Yes?
Yes, sir.
And if I multiply this here, sorry, here I have a 5 electrons. So if I multiply this, the low second equation with the 2, I will get the 10 electrons. So if I multiply the second equation with the 2, it will become 1. Water become 6. This become 2. This become 12. And this become 10. Is this understandable? जी, यहाँ तक क्लियर है सबको? अगर किसी को बेटा कोई कंफ्यूजन है तो प्लीज पूछ लें. Okay, then have a look at the net equation. we have a equal electron, so I can cut the electrons on both sides. If you see, there are 10 hydrogens over here and 12 hydrogen over here. So these 10 hydrogens would be cancelled out, and here you are left with the 2 hydrogens. If you see, here I have a 10 water and here I have a 6 water. So all this 6 water cancel out, and here I am left with the 4 water. 6 water cancelled out and 4 water over there. Is this clear? So if I'll write the equation, it would be 5H2O2 plus iodine. There is nothing else on the reactant side. Then 4H2O and 2IO3 negative ions. Yes. Is this clear to everyone?
Sir, won't you like 2 hydrogen ions too?
Sorry.
2 hydrogen ions on the right hand side.
Sorry, I overlooked 2 hydrogen ions as well, because we are left with the 2H positive. Yes, is this clear to everyone?
Yes, sir.
Yes, sir.
Okay. Now, in the next part, write the overall equation for the decomposition of H2O2 catalyzed by acidified IO3 negative. Yes. What is the role of IO3 negative over here?
Catalyst.
Catalyst. So if it's a catalyst, so it means it remains unchanged at the end of the reaction, right? Yes. So it means that H2O2, here I can write IO3 negative to show its catalytical activity. And whenever H2O2 decomposes, it forms water and oxygen. To balance the equation, I have to put half. Is this clear?
Yes, sir.
So can you solve it by using our equation in part 1 and the equation given?
Yes, we can solve it in that way as well.
Right.
For this, have a look over here. Just give me a minute. If we compare equation, second equation and the third equation. Okay. Okay, let's have a look. I have IO3 negative reacting with 6H positive and 5 electrons. Forming half mole of iodine and 3H2O, right? And its value is positive 1.19. So if I compare these two equations, as its value is smaller, which means it will undergo oxidation, and if it would undergo oxidation, then I will flip its equation, right? So if I'll flip its equation, it would be H2O2 2H positive plus O2 plus 2 electrons, and its value is positive 0.68. So that's why I have flipped this equation. ये बात यहाँ तक clear है? Okay. So if I add these equations, first I have to equal the number of electrons on both sides. So if I multiply the first equation with the 2, so here I got 2, 12, 10. 2 times half gives me 1, and 2 times 3 gives me 6. And the second equation I have to multiply it with 5. So 5 over here, 10 over here, 5 over here, and 10 over here. So if you see, first iodate, 2 moles of iodate reacts with 5H2O2, forming, 1 minute, let me cancel the electrons, 10 and 2H positive are left over here, and that's it. Okay, so 2 moles of iodate ion reacting with 5 moles of H2O2 plus 2 hydrogen ions, forming iodine, 5O2 and 6H2O. Is this clear? Okay, now if you have a look over here, the reaction, the equation we have made when hydrogen peroxide reacted with iodine, and here we have the equation made when hydrogen peroxide reacted with iodate. Okay, so now if you add these two equations, so see, iodine are on the opposite side, so they must be cancelled out. 2 iodate ions are on the opposite side, they must be cancelled out, right? 2 hydrogen ions on the opposite side, so they must be cancelled out. Now we are left with 5H2O2, and 5H2O2 gives me 10H2O2. There is nothing else on the reactant side. If you look at the product side, 4 water and 6 water forming 10H2O and 5 moles of oxygen. So if I simplify this equation, Aren't I getting this one? Yes, is this clear?
Yes, sir.
Okay. So for 1 mark, this is the plenty of working. So it's better because directly write the equation as we get to know that it is behaving as a catalyst. अगर किसी को कोई confusion है तो please पूछ लें. Okay. Part D. Student collects some data for the reaction of H2O2 with acidified IO3 negative as shown in the table. Okay. Use the data to determine the order of reaction with respect to H2O2, IO3 negative, and hydrogen ion concentration. Show your reasoning. Order with respect to H2O2. Okay. So for H2O2, I can take experiment 3 and 4 because in experiment 3 and 4, these concentration of iodate are same, concentration of hydrogen are same, but the concentration of H2O2 is increasing by some factor, and in the similar way, the rate is also increasing by some factor. So can anybody tell me the factor by which the rate and the concentration is increased?
Rate is
1.5.
increased by
It's 1.5. What about the rate?
Same.
Find the factor of rate. 8.82 divided by 5.88.
1.5.
It's 1.5 again. So see. So what it tells me that both the concentration of hydrogen peroxide and the rate are changed by the same factor, which means it's first order. So how could I state this as they have asked you to show your reasoning? So I can state that from experiment 3 and 4 as the concentration of hydrogen peroxide is increased by the factor of 1.5, the rate also increases by the factor of 1.5, hence its first order with respect to concentration of H2O2. Yes, is this understandable to everyone?
Yes, sir.
सर ये कैसे पता चला कि अगर उसका फैक्टर ऑफ 1.5 से इंक्रीज हो तो होगा उसका
आपकी आवाज डिस्टॉर्टेड आ रही है ताहा।
सर अगर फैक्टर 1.5 से इंक्रीज हो रहा है तो हमें कैसे पता चला कि फर्स्ट ऑर्डर है उसका
देखें फर्स्ट ऑर्डर का मतलब क्या होता है? फर्स्ट ऑर्डर मींस if the rate concentration is doubled, then the rate is also doubled, right? If the concentration is increased by 4 times, rate is also increased by 4 times.
Yes, sir.
Yes, Taha. So see, concentration 1.5 के फैक्टर से इंक्रीज हुई है एक्सपेरिमेंट 4 के लिए, और रेट में भी क्या चेंज आया है? 1.5 का ही चेंज आया है।
Yes, sir.
तो दोनों का चेंज सेम है, इट मींस इट्स अ फर्स्ट ऑर्डर।
सही। तो मतलब सर हम लोग रेशियो का सॉर्ट ऑफ करेंगे, अगर दोनों का 1.5 और 1.5 होगा तो 1 होगा वो।
यस।
सही सर।
और अगर फॉर एग्जांपल दे ऐसा होता कि इसका फैक्टर 2 से चेंज हो रहा होता,
सर
ठीक है, इसका फैक्टर किससे चेंज हो रहा होता? 2 से चेंज हो रहा होता, और ये वाला फैक्टर 4 से चेंज हो रहा होता, तो
सर ये सेकंड ऑर्डर होता है 4/2।
कॉन्सेंट्रेशन और रेट का रेशियो क्या आता? 2:4, which means 2:2 raised to the power 2. So it gets a second order, it becomes a second order, right?
ओके सर।
Okay, now order with respect to iodate. So for iodate, which can be chosen. Okay, for iodate, I can use experiment 1 and 3. Okay, what I'm going to do, I'm going to choose experiment 1 and 3. Why is it that? Because here the concentration of hydrogen ion is constant, but the concentration of H2O2 is also changing. But now I am aware of the concentration fact of the order of H2O2. So if it is changing, it does not affect my results. So can anybody tell me the factor by which the concentration of iodate is changed? I think it's 2 times, right?
Yes, sir.
And it is also 2 times.
Yes.
Now, by which factor the rate is changing?
4 times.
4 times. So which means I can write that it is 2 times the rate. So it is changing the rate 2 times due to the concentration of H2O2 and 2 times due to the concentration change in iodate. So the if you look here, the change is again same with the concentration of iodate and the rate. So it's first order again. So I can conclude from experiment 1 and 3 concentration of iodate is changed by the factor of 2 Hence, rate is also changed by the factor of 2. So its first order with respect to concentration of iodate. Yes, is this clear to everyone?
Yes, sir.
Now, order with respect to hydrogen. For hydrogen, which two experiment we can use? Okay, let's take experiment 1 and 2. Here, the concentration of hydrogen is changed by 2. It remains same. And the concentration of hydrogen peroxide is also changed by 2, right? So by which factor the rate is changing?
Two.
Yes, 2. So what we can conclude that we already know that the that it is first order with respect to the concentration of hydrogen peroxide. So this change in the factor or change in the rate by the factor of 2 is due to the change in the concentration of H2O2, not due to the concentration of change in the concentration of hydrogen ion. So it means I can say it's zero order with respect to the concentration of hydrogen ion. Is this clear?
Yes.
Yes, if anybody have any doubt, kindly ask.
सर दोबारा एक्सप्लेन कर देंगे.
Yeah, sure. Okay. हाइड्रोजन पेरोक्साइड की कॉन्सेंट्रेशन किस फैक्टर से चेंज हुई है? यस सोलेहा.
सर 2.
2. और रेट किस फैक्टर से चेंज हुआ है? यस. जी, रेट किस फैक्टर से चेंज हुआ एक्सपेरिमेंट 1 एंड 2 में?
4.
नहीं, चेक करें ना आप एक्सपेरिमेंट 1 एंड 2. These two.
By 2.
By 2. तो it means जो rate change हुआ है, it is only due to the change in the concentration of H2O2 because we already figured it out that the order with respect to H2O2 is 2, right? Is 1, right? ये तो हमें already known है ना, हम तो पहले experiment 3 and 4 से ये बात figure out कर चुके हैं कि हाइड्रोजन peroxide का order 1 है. तो अगर rate 2 के फैक्टर से चेंज हो रहा है और हाइड्रोजन peroxide की concentration भी 2 के फैक्टर से चेंज हो रही है, तो it means rate में जो भी change आया है, it is due to the change in the concentration of H2O2, right?
Yes sir.
और हाइड्रोजन की concentration भी किस फैक्टर से चेंज हुई है? इसी एक्सपेरिमेंट 1 एंड 2 में हाइड्रोजन की कॉन्सेंट्रेशन भी किस फैक्टर
By
से
2.
चेंज हो रही है?
By 2.
बाय 2. मगर इसकी वजह से रेट पे कोई इफेक्ट आना चाहिए ना, इधर बाय 2 या फिर इधर बाय 4, वेदर इट्स अ फर्स्ट और सेकंड ऑर्डर. बट इसकी वजह से रेट पे कोई फर्क ही नहीं पड़ा. रेट फर्दर टाइम्स 2 के अलावा इंक्रीज ही नहीं हुआ,
ठीक है सर.
which means it's a zero order with respect to hydrogen ion concentration. So I can conclude here that from experiment 1 and 2 the concentration of hydrogen ion is changed by the factor of 2, but there is no change in rate so it's zero order with respect to the concentration of hydrogen ions. Yes, is this clear to everyone? जी सबको clear है?
Yes, sir.
Okay. Now in the next part, what they are saying, use your answer to D2 to write the rate equation for this reaction. So rate is equals to rate constant K times concentration of H2O2 raised to the power 1 because its order is 1 times concentration of iodate ions raised to the power 1 because its order is 1, and there is no need to write the concentration of hydrogen ions in the rate equation because its order is 0. So here we have the rate equation. Yes, is this clear?
Yes, sir.
Okay. Now calculate the value of rate constant K using the data from experiment 4 and your answer in D2. So in D2, we have made the rate equation. And if I make the subject K in the rate equation, it would be rate is equals to concentration of H2O2 rate upon concentration of H2O2 times concentration of iodate ions. So now here I have to put the values. So, and which values from experiment 4? It is 8.82 exponent 5, exponent minus 5, sorry. 8.82 exponent minus 5 over 0.150 and 0.140. 0.150 times 0.140. Yes, can anybody tell me the answer?
4.2 exponent minus 3.
4.2, and there is no other figure after 2, Hamna?
No.
So you may write 4.20 because you have to keep 3 significant figures in your answer. So it's 4.20 exponent
Minus 3.
minus 3. Now you have to find the units. So see, the unit of rate is mole per dm cube per second and the concentrations are mole per dm cube. So mole per dm cube per second in the numerator as rate is in the numerator, and in denominator I have mole per dm cube times mole per dm cubes because I'm taking the product of two concentrations. So these two would be cancel out and you are left with, when you take the mole in the numerator, it becomes inverse. Then second inverse is in the numerator as well. And dm cube when goes to the numerator, it would become dm inverse cube instead dm cube. So mole inverse dm cube second inverse. or you can write in this order as well. Is this clear? Yes, is this clear to everyone?
Sir.
Yes, sir.
Okay. Key part. Lead iodate is only sparingly soluble in water at 25 degrees Celsius. The solubility product KSP of lead iodate is 3.69 exponent minus 13 mole cube DM inverse 9 at 25 degrees Celsius. Write an expression for the solubility product of lead iodate. Okay. So first make the chemical equation for the dissociation of lead iodate in water. So I'm going to get lead ions with a 2 positive charge and 2 moles of iodate ions. So if I'll write the KSP expression, it is the concentration of lead 2 positive ions time concentration of iodate negative ions raised to the power 2, because there are 2 moles over here. Is this clear?
Yes, sir.
Okay. Now what they are asking? Calculate the solubility in mole per dm cube of lead iodate. So if you see, the mole ratio of a lead iodate and lead ions is 1:1. So can I equate this that the constant solubility is the concentration of lead iodate ions, which is equal to the concentration of lead 2 positive ions, right? If I get the concentration of lead 2 positive ions, I'll get the concentration of the lead iodate molecule salt, and that would be its solubility. See, it's in mole. So if I don't know how much moles are present, so I can equate it by there must be X moles of lead ions, and if there are X moles of lead ions, the iodate ions would be 2x. ये बात clear है सबको?
Yes, sir.
So this must be equal to x. If I find the value of x, I'll find the solubility. So if we put these values in the KSP expression, the value of KSP is 3.69 exponent minus 13. So 3.69 exponent minus 13 is equals to x, that is the concentration of lead, times 2x, that is the concentration of iodate raised to the power 2, which would become 4x cube. So if I find x, x would be cube root of 3.69 exponent minus 13 over 4. Is this clear?
Yes, sir.
Can anybody tell me the answer?
4.518 exponent negative
4.518 exponent
5.
negative 5. So 4.518 exponent negative 5 is the answer. Yes. Is this clear to everyone? If anybody have any query or question, kindly ask. Okay. Now the F part. Ammonium iodate is an unstable compound that readily decomposes when warmed. The decomposition reaction is shown. Okay, here I have an equation. And I have provided with the enthalpy change, which is exothermic. Use the data in the table to calculate the entropy change of a reaction of the decomposition of ammonium iodate. So if you recall the entropy change, that the entropy change is equals to sum of the entropy of the products minus sum of the entropy of the reactants. So let's start. We have a half mole of nitrogen. So I would do 192 over 2 plus I have a half mole of oxygen. So I would do 205 over 2. I have a half mole of iodine. So I would do 261 over 2. Then I would 2 moles of water. So I would do 2 times 70, and sum of all these give me the sum of the entropy of the product, right? Minus entropy of the reactant, which is NH4IO3, and its entropy is 42. It's 1 mole, so I just put 42 over here. Yes, answer please.
427.
427, positive or negative?
Positive.
Positive 427. So I would write over here positive 427. Is this clear? Now, this reaction is feasible at all temperatures. Explain using the data in F. Okay, here. And your answer to F1. Okay. So, from here, what? Okay, first recall how we will calculate the Gibbs free energy. Gibbs free energy would be delta H minus T delta S, right? And for this reaction, delta H is negative, right? And delta S is positive. So see over here, whatever the value over here, it's a positive. We have a negative sign. Whatever the, whatever the value over here is a negative. Delta S is negative. So whatever the temperature I would take, the Gibbs free energy always stay negative, right? Gibbs free energy की value क्या positive हो सकती है इस केस में? Sorry, delta S positive है, तो minus delta S negative ही रहेगा और delta H negative है. तो जब आप ऐड करेंगे तो आपका आंसर जो है वो हमेशा नेगेटिव साइन के साथ ही आएगा. So at any temperature, we would get delta G negative. And if it's delta G is negative, then it's a feasible, whatever the temperature we choose. Yes, is this clear? जी अगर किसी को कोई कंफ्यूजन है इस पार्ट में तो प्लीज पूछ लें। Okay, so I'm keeping the class till here and we will continue from here in our next class. Okay. Next question, question number 4. Okay, take care everyone. Allah Hafiz.
Officer.
सर कल क्लास होगी?
Hopefully I'm trying that I will take a class tomorrow as well. Let's see.